Okay, hi everyone. Sorry for like the background noise. So the last time we learned about the double angle and half angle formulas so that we have more tools to establish the new identities. And as for today, before we actually get to 9.1, I would like to have a quick recap on what we've done so far in this class. So we started with chapter 7. Let me put chapter 7 right here. And later on, we're going to talk about chapter 8 in a minute. For chapter 7, the very first thing that I show you guys is to convert from degrees to radians. So hopefully everyone knows how to do it by now. If you don't, make sure you let me know, okay? So it's just a matter of like choosing whether you should multiply by 180 degrees and divide it by pi radians or vice versa, okay? So you have to know which one to use when, okay? And the second big topic that we learned is about the arc length. So let me just put arc length in here. And then we have the formula for it, which is S equals to R theta, where R in here is a radius and theta would be the angle. And make sure you have to use radians, not degrees for theta, okay? If you go ahead and use degrees, you're going to get to the wrong answer, okay? So watch out for it because on the exam, you're going to have this formula. You have to use it and make sure you use it in radians, not in degrees, okay? And we also learn about the area of the sector. So let me just put area of sector in here. And I'm so sorry for my bad writings. We have a formula. Pull this away. Okay, the formula for the area, it goes like A equals to 1/2 R squared theta, where again, R is a radius and theta would be the angle. And make sure for this theta also, you have to have it in radians, not degrees, okay? Else everything will be wrong. And as you see in the first quiz, we also have the second formula for the area of the sector. It goes like 1/2 R times S. As we can replace R theta, one group of R theta right here, with S. So this one is to find the area of the sector when you know the arc length, or when I ask you to use the arc length to find the area of the sector. The outer formula, this one in here, you use it to find the area of the sector if you know the angle, okay? So this one in here is for the angle, and the one in red is for the arc length, which is S. Or let me just put arc and then length, okay? So don't get confused. Make sure you know which one to use when. And the third formula, the third big topic that we talked about is the CAT, the complementary angle theorem. So the big ideas about the complementary angle theorem is about the cofunctions. Okay, so as you guys experienced in the first exam, cofunctions are the trig functions that go in pairs, okay? For example, the cofunction of psi is cosine, the cofunction of secant is cosecant, and the cofunction of tangent is cotangent. As you guys can tell, the quick way to remember the cofunctions is that they go by names, right? So except for sine and cosine, or even like for sine and cosine, they have sine in between, right, in common. Tangent and cotangent, they have the word tangent in common. Secant and cosecant, they have secant in common. So the names will like give you the way. So make sure you know what cofunctions are, okay? And we also know the identities. So we have 3 type identities in here. The reciprocal, for example, we have something like secant is a reciprocal of cosine. And we also have quotient identities, which tells you that tangent equals to sine divided by cosine. And the last type of identities is the Pythagorean identities, where we have sine squared plus cos squared equals to 1, and tan squared plus 1 equals to secant squared. And also we have cotangent squared plus 1 equals to cosecant squared, okay? So make sure by now you memorize all of those identities because they are really useful and you have to memorize it anyways for the final and the second exam. We also learn about a reference angle. So let me just put ref in here for reference angle. And after that, we have even and odd function. So as you guys can see, reference angle is a big topic of this class of trig, right? So you use it a lot. When do we use reference angle? When we have a big angle. For example, if I'm asking you to find psi of, I don't know, 390 or something like that, this is way too big, right? And then we don't have it in the chart diagram you guys memorized. So how can we get it? We have to convert, or we have to get the reference angle of 390, and then after that, is something doable, and then we calculate or like match up with the chart diagram you guys memorized to get the value of it. But be cautious that just because you have the reference angle, it doesn't mean the answer is always positive, right? Sometimes the answer could be negative, especially, for example, in this case, 390 is not in the first quadrant, right? So you have to draw it out to see what quadrant you're in to make sure whether your value is positive or negative, depending on the all students take calculus thing, okay? And for even and odd function, for example, you're going to get something like, I don't know, psi of negative 390 degrees. So what does the even odd property do to the psi of negative 390, right? So if it's odd, like sine here, then the negative would be brought out. So let me put it in green. So this equals to negative sine of 390. And if it were to be cosine of negative 390, then it would turn out to be cosine of positive 390. Because for odd, the negative would be brought outside. So let me just put like the negative in here. And this one is like the symbol for you bring it in front of the trig function, or like outside. And make sure that you don't put the negative in between of psi and the function, or like between psi and the angle. It looks really weird. Don't do it like psi minus 390. First of all, it doesn't make any sense, because if you want to have a negative angle, you have to put it in like parentheses, okay? And don't do something like psi and then minus next to it and then 360. Or don't think about it like psi minus 360, because none of these make sense, okay? So let me get these out the way before it gets to your brain. So don't remember it. It's wrong, okay? It's just wrong. I'm really bad with this thing. I don't know how to use it, so let me just erase it manually. Okay, sorry for taking too much time. Alright, done with that. And for even, okay, for even function, you can just cancel the negative. So let me just put cancel. And what do I mean by cancel? For example, if you have something like cosine of 30 degrees, it equals to cosine of negative 30 degrees. Okay, so as you guys can see, the angle from negative now is positive, and vice versa. Okay, for even functions, even if you have a negative angle, it turns out to be a positive angle at the end. Okay, so ignore it, cancel the negative. Okay, and the next big topic that we learn is how to figure out the value of 6 trig function using right triangles. I believe that you guys are really good at this one already, but let's say, for example, if I'm asking you, like, I give you something like psi of theta equals to like 1/2, then you have to draw the right triangle in the right quadrant given some like condition. For example, like cosine has to be like negative or something like that. You have to decide what quadrant where psi is positive and cosine is negative is. And after that, you draw a right triangle, and then you figure out all the other remaining like trig functions, okay? You saw it in the test or in the quizzes already, so I'm guessing you guys are familiar with that. But if it doesn't make sense to what I'm saying right now, please let me know. Just email me saying, like, at this moment, at this minute on the video, I can't not understand what you're saying, okay? Just let me know. So let me just put like a symbol of like a quadrant in here, and then this one is like a right triangle, where this one is a theta, and then you label it, and you use a Pythagorean theorem to figure out the missing psi, and then you go to find the other remaining functions from there, okay? And the last topic in chapter 7 is the graphs. So we went really fast over the graphs of all 6 trig functions, and I told you guys I'm not going to expect you guys to remember the graph of cotangent, cosecant, and secant, but if you guys want to prepare for the final starting from now, you have to know how to tell the difference between each graph, okay? I'm not going to expect you guys to like know how to draw the graph, but you have to remember what shape of it, like what it looks like. So if I, for example, if I give you guys something like a wave, you have to tell me that is either sine, cosine, okay? So for example, if I give you guys something wavy like this or like that, then these are either sine or cosine, okay? And if I give you guys something like Egyptian dance, something that looks like this, or something that looks like this, it's either tangent or cotangent, okay? So I usually call it by Egyptian dance because it looked like it, but like figure out a way to memorize it, okay? If like whatever makes sense for you, do it. And the last high of function is the cosecant and secant. if you guys see something like a teeth, like a jaw of teeth, something like this, like, I don't know, like this, or the other way, like this, and that. Sad face, happy face, whatever you want to call it, or like a jaw of teeth. These are either cosecant or secant, okay? So make sure you guys can tell the difference between the 6 graphs, okay? That's all I'm asking for. And one more big thing about a graph is that you have to memorize the domain and range of all 6 trig functions. So as a recap, the domain of sine and cosine would be all real numbers, while the range of sine and cosine should be from -1 to 1 inclusively. And the domain for tangent and secant, I think, should be all real numbers except for like the asymptotes. And at this point, I don't want to give you guys like the wrong answers, so make sure you guys jump to your review right now to make sure it stays in your head and ready, okay? So make sure you guys memorize the range and the domain of all trig functions, okay? Just to prepare ahead for like the exams, exam 2 and the final. All right, so enough talking about chapter 7. About chapter 8, the first thing we learn is the inverse function and how to solve for the inverse function, right? So what do I mean by solve for the inverse function? For example, if I give you guys something like, okay, let me put this in green first. Okay, so if I give you guys something like y equals to psi of x plus 2 minus 1, you guys have to do the algebra a lot to solve for x, and at the end you have to interchange x and y and then replace y with f -1 of x, which is f inverse of x, like the inverse function of f. Okay, so make sure you guys can do it. Make sure you guys remember how to do it. Okay, and after this we learn about the inverse trig equation. So this time we're talking about the equation. It means that we should have 2 sides rather than 1 side of the problem. And a typical example for this topic would be something like, I don't know, psi inverse of x equals to pi. So when you see something like this, I told you guys we have to invert it inside out, okay? So the next step in here, you would have to do something like psi of pi equals to x. But this is not the final answer, okay? I'm not going to accept it if you just put x equal to psi of pi, because you do know the value of psi pi, right? Pi in here is one of the quadrantal angles, so it's either like in the spot of 0 degrees or 90 degrees or 180 degrees or 270 degrees. So when you're there, make sure you draw the unit circle and then you label the points as like 1, 0, 0, 1, -1, 0, or 0 and -1, something like that. And the first coordinate would be cosine, the second coordinate will be sine, right? So make sure you can find a value of psi pi based on that, okay? Moving on to the next topic, we also talked about the composite functions. We have 2 types of composite function. If you guys recall the purple sheet that I give you guys the other day, like the one that I put on Blackboard and the one that we went over in class before we went online. So a typical problem of these type would be something like secant inverse of cotangent of 0. And in here, a recap, I told you guys, so if the outside function is the inverse function, what are we looking for, an angle or a value? At this point, if you guys don't remember it, please double check in the notes that I gave you guys, okay? So make sure you guys have to do something like this. It's also in the quiz 3, so please make sure you do know how to do it real good before the exam comes, okay? Don't wait until the last minute to ask me for help, okay? It's gonna be too late. And another topic that we learn is to solve for the trig function. So solve trig function. And I'm so sorry for my bad writings again. Okay, so a typical problem of this type would be something like cosine square of, I don't know, theta in here plus 2 cosine of theta plus 1 equal to 0. And I'm so sorry if my theta look like a plus. It's meant to be like a circle thing for theta. So let me just make it bold like this, okay? So the quick way to do this one is recall the factoring methods, the X method, diamond method, whatever you want to call it, that you learned in high school or like whenever in the past. If you want, if it's easier for you, treat the one function that you have in the problem like X. For example, we have cosine here. being like the trig function, the only trig function in the problem. So we're gonna start by saying x equals to cosine theta, and then we will replace cosine theta with x. So technically we're gonna have something like x squared plus 2x plus 1 equal to 0. And from here we solve for x, and at the end make sure you substitute it back for cosine theta, solve for theta, you get the angle, you done. Okay. And the most recent topic that we learned is about a sum and difference formula. So I hope you guys have a good practice for it. The homework is due last week, so if you have any questions on the homework or on the practice problems or just like anything at all in the lecture notes, please let me know. Please just email me, okay? And again, to prepare for the exam 2 and final, you have to memorize the formula. You have to memorize the 6 formulas for the sum and difference. Like for psi, 2 formulas for psi, like one for the sum, one for the difference. 2 more formulas for cosine, one for the sum, one more for the difference. And also 2 more for tangent, one for sum and the other one for difference. Okay, so make sure you memorize all 6 of them, because in the quiz, even if you try to like look back on the formulas, it will take some time. So it's just better to keep everything in mind, so then when you need it, you just pull it out. Like personally, I think it's gonna be more convenient. Okay, and then on 8.6, the last topic on 8.6 is about the double and half angle. And again, for double and half angles, we have some formulas in here, so make sure you know the formula psi of 2 theta, the formula of cosine of 2 theta, which has like 3 formulas in there. Like there are 3 versions of cosine of 2 theta, so make sure you know all of them. But if you like wise, make sure you know at least one formula of cosine 2 theta, which is cosine squared minus psi squared. And the other 2, you can just base them up on the Pythagorean identities and just derive them if you need it. Okay? And the last topic of chapter 8, as I remember, is to establish identities. So I'm going to give you guys like an identity, like an equation. So what you need to do is to go from one side of the problem and manipulate with it, do whatever you want with it, as long as you get to the other side of the problem, okay? So don't ever solve it by like 2-column proofs or like whatever you want to call it. But don't go sideways. You have to start from one specific side, usually the more complicated side, and try to get it look like the other side, okay? So if it's not clear, if you have like any concern about this topic, please let me know. Just email me, okay? All right, enough saying. Let's get to the main topic of today. Okay, so the first topic of 9.1. Oh, really quick before we actually start the lesson. Okay, I also attach like the practice problem in here if you guys want to try it out. So I give you guys some problems so you can try it at your own. It's not gonna count toward anything, but just in case like you need more like practice to get yourself ready for exam 2 and for the final, make sure you do these. And if you want the answer, email me. I'm gonna see whether your answer is right or wrong. Okay. And for the last part, I put question marks in here because I think word problems are usually the hardest, but I'm not really sure like how to help you guys with that. I mean, like I give you guys all the methods I could think of, but if you need more help, please let me know, okay? So if you feel like shaking, if you feel like worried about the word problems that I might put on the exams or on the quiz, make sure you do like some problems in the homework and even in the textbook, like the one that you haven't done in the homework. Do them all if you have time, okay? So then you have like a different flavor, a different like taste of what's going on like in real life situation. That's my purpose, okay? And I'm not gonna waste your time anymore. For chapter 9, the first one, 9.1, we're gonna talk about the applications involving right triangles. So to me, this one should be the easiest topic that you learned so far, because this one you already learned it. It's like the angle of elevation is the word problem that you guys have trouble with in the first exam. But if you think about it, you only need 2 things to work. You only need to know like 2 things in here. You only need 2 tools in here. The first tool is, as long as you know the SOHCAHTOA, you're good to go. The second tool is that as long as you know the triangle sum, which means that all angles in the triangle add up to 180 degrees, you cool. You'll be fine. Okay? So, today we will learn how to solve a right triangle and apply this knowledge to real-world problem. So what does it mean by solve for a right triangle? We know that every angle has 3 sides and has 3 angles. So to solve for a right triangle or to solve for any triangle, it means that you would have to find all the measures of all the angles and you have to find all the lengths of all the sides. Clear enough? So what should you expect for the final answer? You should have 6 answers, okay? 3 for the angles and 3 more for the side lengths. All right. So the labeling system, let's just do it as like a convention for this class. So angle C is always going to be the right angle in here. So let me put it in blue. The angle C would be the right angle right here. A would be the angle on top and B would be the angle on the outer side. And if you want, you can switch the position of angle A and B. I wouldn't mind. I won't mind. Okay, like do whatever that you feel happy with. Okay, but for the sides, they have to stay in order. Okay, for example, for the side A, if you look across from angle A, whatever that side is, you have to name it A. And if you look across from angle B, you have a side, whatever that side is, you call it B. And if you look across from angle C, whatever size you have to call it C. Okay, so let me just redraw the length side of A. Okay, so if it's not clear, please let me know. Okay, and then a quick review in here is that we know by Pythagorean theorems, we know that a squared plus b squared equals to c squared, where c is the hypotenuse, always the longest side. So as you can tell, c in here, because it's opposite to the right triangle, to the right angle, it should be the longest side, right? And it should be also the hypotenuse. For A and B, it really doesn't matter the order. You see it already in class. It doesn't matter which one you go first because addition, you can switch up the order, right? And know that because we have all 3 angles, A, B, C, add up to 180s in a right triangle, in any triangle, right? So in here, if we do the math, we should have something like angle A plus angle B plus angle C equals to 180. But since angle C is 90 degrees already, we substitute 90 for angle C, we rewrite angle A and B, and at the end we're gonna minus 90 degrees from both sides, and we will have something like A. Okay, it doesn't let me write it, so let me come over here and put A plus B equals to 90 degrees. Okay, that's why we have this result in here. Okay, and as for a quick review, we talked about SOHCAHTOA. So make sure you know all the definition of SOHCAHTOA. For psi is always opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant, it will be the flip of sine. Let me change to yellow. So cosecant, it will be a flip of sine. Secant, that would be the reciprocal of cosine, and cotangent will be the reciprocal of tangent. Okay. So if anything, you just have to know the SOHCAHTOA and remember the reciprocal identities, and you're good to go. Okay. And just recap really quick in here. Make sure that you always label angle C for the right angle, okay? So the right angle right here, the only right angle that we have in a right triangle in here is always C. Don't call it A, don't call it B. It has to be C because I said so, okay? And moving on to the next page. So as I was saying earlier, to solve for a right triangle, it means that you have to find all the missing lengths and you have to find all the missing measurement. So technically, you should expect 6 answers in this type of problem. If I'm asking you to solve for any triangle, I'm expecting to see 6 answers, okay? No matter if like one of your angle or one of your side is already given by the problem, you have to conclude it in your conclusion also, okay? So, okay, I mixed up in here when I put the word 6 angle. I meant 6 answers. And what are these answers? I need 3 angles. It doesn't let, okay, there we go. I need 3 angles And I also need 3 sides. Okay, and add them up, we're gonna have 6 answers. Okay, so here are some tips before we jump into the example. You need to memorize the SOHCAHTOA. Okay, that's like your tools in here, your biggest tool in here. Okay, inverse function, you guys will see it soon in the in the word problem. In yeah, you guys will see it in the next page. But keep in mind that you have it to use. Okay, and when it comes to solving a triangle, it really doesn't matter the order of which one you find first. For example, if you're missing A, B, C all together at once, you don't have to go in like alphabetical order. You can solve for C first, and then after that you do A, and then you do B at last. Okay, you don't have to go in order. You don't have to go in any order. As long as you can solve for like whichever one of them, go for it first. Do the easy one first, and then do the harder one later. Okay, you don't need to go in any order at all. Okay. Right, so let me delete my marking here really quick. Okay, so as for convention, whenever I give you like a problem without diagram, make sure you know how to draw this diagram. Okay, so let me box this diagram in here. So again, C is always the right angle, and look across from it, you can have the little c for the side length. And A and B, you can change them, you can keep them the same as this picture, it doesn't matter, suit yourself, okay? For example, if I throw at you this hard problem, given that C equals to 10, A equals to 40, you have to find A, B, and big B, okay? So you might want to ask me, well, a triangle has 6 answers, right? Or like 6 number. We have only 1, 2, 3, 4, 5 in here. So where's the 6th one? The 6th one in here is C. The measure of angle C is 90 degrees, always, at least for right triangles, okay? So you don't have to find it. Okay, so now that you know C and A, to my like experience, I want to deal with angles first because like they're usually a nice number, and I have to memorize that A plus B equals to 90. That's all I need to know, right? So in here, we given that A equals to 440, so B equals to 50. That's done right there without effort, right? So that's an easy one. So we done with solving for B. That's good. So between A and B, the little a and the little b in here, it really doesn't matter which order you find first. Even though the question asks you to find B first or A second, you don't have to do it. Like if you can find A first, go for it. If you can find, yeah, like the way that I did in here, I found A first and I found B secondly, not because they are in like alphabetical order, just because I wanted. Okay, just because it's more convenient for me to do like A. That's why I went for A. Okay, but for you guys, do whatever that's more convenient for you. You don't have to go in any order, okay? Okay, so how can I find a psi? The psis are harder a little bit in the sense that you have to know how to use a SOHCAHTOA in here. For example, because I know C already, and C in here is the hypotenuse. If I want to find angle, actually, okay, so here's the thing. I have angle A already, which is 40, right? So let me notate it right here. A in here equals to 40 degrees. So I'm going to go ahead and use psi of A. Why? Because I want to find the little a, okay? If you don't like it, you can use cosine of A to find the little b. It's going to go something like cosine of A equals to adjacent over hypotenuse, and adjacent in here would be B, hypotenuse is C. We know C, we know that A is 40, we plug them in. So cosine of 40, if you plug it into the calculator, it's gonna give you something in here. B is missing, C in here is 10, right? So whatever thing that you have in here in decimal, put it over 1, and then after that, we're gonna do cross multiply. So we have that thingy with 10 times 10, and we have B times 1, and then we still get B, okay? And after that, you can find A. That's the second way, like compared to the key. In the key, I want to go for A. No, like, excuse, but yeah, I just want to find A. So the way that I did it is that I solved for A by using the function or like the formula of psi. I know that psi equals to opposite over hypotenuse. So I know that A equals to 40, and I plug it back in here. Hypotenuse is C. C is 10. I put it back in here. And again, psi of 40, it gives you something like weird. not weird, but like it's gonna give you a bad number. Okay, and you just have to put it over 1 in here. And after that, you do cross multiply. So you times 10 with sine of 40, and you times a with 1, which gives you a on one side equals to 10 times sine of 40 on the other side. And on this point, at this point, you just have to plug it into the calculator, and then you get a decimal version of like your answer. Okay, so now that we got a, if you want, you can do this way in here to solve for b. So b would equal to cosine of 40 times 10. Or if you don't like it that way, you can use the Pythagorean theorem. We know that a squared plus b squared equals to c squared. So if you want to solve for b, put it to the other side, and we're going to have something like b equals to square root of c squared minus a squared. We know that c equals to 10, and a we just found it, which is 6.42. We plug them in, hit it into the calculator, you get your final answer. Okay? And because the question is only asking us for A, B, and the big B, we just have to say those 3 things. That's all. Okay? You don't have to say like all 6 of them, even though it's like given in here. I'm not going to be like super tricky about this one. So if you will give me all 6 answers, I'll be fine with it. If you just give whatever answers that the question asks you, I'll be fine with it too. Okay? So try yourself with this problem right here. It should be like okay, it should be doable, but if it's not, let me know. Okay? And moving on to the next page, which is the last page of today. Okay, so in math, we handle the right triangles in the problems that we just did. It's easy enough, right? Like it should be easy enough, I think. Oh, and by the way, okay, let me go back to that page really quick. Okay, let me put this in, I don't know, red maybe. Okay, so you guys should expect to see something like this. Let me highlight it. You guys should expect to see something like this in quiz 4. So let me just put Q4. Okay, it looks bad. Let me erase this thing and then put back. So you guys should expect something like this in quiz 4. Okay, so make sure you practice it, have a good understanding of it. If not, please let me know. Okay, and moving on to the last page for real this time. Okay, so what do we do with this page? Generally, we have all the tools that we need in here already, and specifically in a right triangle. I told you guys the relationship between angle A and angle B is that A plus B equals to 90, okay? So let's just write it down instead of like keeping it in our head. So we know that A plus B equals to 90. We have SOHCAHTOA. And we also know that a squared plus b squared equals to c squared. So these are all the tools that you have. If you're talking about angles, then you have to go for the first or the second tools. If you looking for the size, then you have to use the last tools in here, or maybe sometimes the second tool in here. So it really depends on what you have and depends on the problem. Okay. So in here in section 7.3, we use right triangle trigonometry to find the length of unknown sides of a right triangle, given the measure of an angle and the length of side. Okay, this just means that you saw it already. Like it's just something we did in the past. It's something that you had in the first exam. Like remember that one word problems where you have to use 2 different right triangles and you have to use SOHCAHTOA to solve for each of them. That's the one I'm talking right now in 7.3. Okay, for the next bullet point, we have now we know inverse trig functions and now to solve for trigonometric equations. So we can solve or apply problems that require finding the measure of an angle given the length of 2 sides of a right triangle. So sometimes it would be situation like I don't know, like like we have to build a bridge or something like that. For example, like here's a land, here's a mountain, and there's a river in between. So this one in here would be the distance from the land to the mountain, and say this is the cliff, and here like this point here would be the top of the cliff or the mountain. And then we have to measure the angle to build a bridge, this red bridge. So we're looking for an angle in here from the land or from the river all the way to the top of the cliff, so that we can like build a bridge in between the land and the top of the mountain for like, I don't know, transportation, something like that. Okay, so when it comes to problems like this, sometimes they're gonna ask you to find the angle, and they're gonna give you like the distance between the land to the mountain. Say this one is like 50 meters, and the mountain is gonna look like, I don't know, like 20 meters. And this one, I know the numbers are not like super realistic, but just treat it like a model, okay? Like a model, like up mountain and the bridge. All right, so let's go to the first example in here. The eye of the basketball player are 6 feet. So to my habit, I usually circle all the numbers on the data that I have in the problem, just so I know I have to use them up. Okay. Usually in math, if you don't use up all the numbers, that means there's something wrong, unless they want to trick you. And I'm not going to be that like evil. I'm not going to trick you in this class. So you have to make sure you use all the numbers that are given. Okay. If you don't, you screw. Right. So 6 feet is the first number that we have. The eyes of the basketball player are 6 feet above the floor. The player is at the free throw line, which is 15 feet from the center of the basket rim. What is the angle of elevation from the player eyes to the center of the rim? Okay, so in here the diagram is given already, and then they are nice enough to like label it for you. And also I'm nice enough to like put a picture for you, right? Like instead of making you draw all over again. But let's talk about it really quick. So we know that the height of the basket is 10 feet, and the height of the player is 6 feet, right? So right off the bat, the sign here, the distance from the basket to the head level of the guy, it should be 4, right? How do I know it? I'm gonna do 10 minus 6. That's why I get 4 right here, okay? And why do I need to pay attention to that gap, to that little like distance of 4 feet? Because that little distance, the black distance in here, is a part of the right triangle that we have. Okay, so if you guys don't notice, this one is a right triangle, and the right angle is like right here. Okay. And after that, what do? The question is asking for the angle of elevation, right? Which is this angle in here. If you want, call it theta. Okay. And what do we know about this triangle? We know 15, we know 4. What is 15 to the angle? Is right next to the angle, so it's adjacent. Let me put adjacent in here. And the 4 in here is right opposite to the angle, so the 4 would be opposite. So by SOHCAHTOA, the only function with opposite and adjacent is tangent, right? So what do we do after that? We have to set it up. By TOA, we have tangent of theta equals to opposite divided by adjacent. And now we know that opposite is 4. So we plug it in. Adjacent is 15. And we also plug it in. So we have tangent of theta equals to 4 divided by 15. And after that, we're going to calculate the angle. Okay, this one is a common mistake. This one is like whether you know how to use your calculator to get to the answer or no, okay? So if you were to put this in a calculator and you do something like tangent of 4 divided by 15 into the calculator, this is wrong. Why is it wrong? Because tangent doesn't stay right next to the fraction, right? Tangent has a theta in between the fraction. That means you cannot do it like this. This one is a big no-no. Don't do it. If I give you something like tangent of 4 divided by 5 or like 15, this is what you input into the calculator. If I don't give you something like this, don't do it. Okay? If you see some like thing in between the trig function and the fraction, it means you have to use inverse function. Okay? So on a calculator, to find the angle theta, you would have to do tan inverse. If you don't know how to get to that button, usually there's like a second symbol or like the shift symbol in there. So make sure you do shift or second. It should say something like this in a calculator. And then you go for tangent if you're looking for tangent inverse. If you want to do something with sine inverse, do shift and then psi. If you want to do something with, I don't know, cosine, do shift and then cosine, okay? It's on the notes also, so make sure you look for it if you need help with it. I'll just email me, okay? So what you actually input to the calculator is tangent inverse of 4 divided by 15, and then you get the answer. And as a part of the question, I forget to mention, but just write off your answer to 1 decimal place. So in here, I'm going to have 14.9 degrees, okay? In the test and in the quiz, I'm going to ask you guys to write off to 2 decimal places, okay? So make sure you stop at the second digit after the point. Don't go further from that, okay? Also, I'm going to take out some points, okay? So now, please try yourself with this problem in here. And for these type of problems, you most likely will have it in the exam, in the final exam. So let me just like circle this type of problem. You will have it in the final exam. Okay, so please be ready for it. And please feel free to ask me any question at any time that you want to, by email or by Zoom. I should be available these days because everything is like shutting down. So if you need help, just let me know. Okay? So thank you for listening to my lecturing. Have a great day. Bye-bye.